Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I'm joined by my co host.
Ben Wilson.
And today we are going to be talking about wisdom with respect to writing code. And before we kicked it off, Ben put it absolutely eloquently. Do you mind just restating what you said?
What did I say? It was, let's talk about how to incorporate 50 years of collective wisdom of software development into the realm of applied data science.
Yeah, and we're going to do this in 30 to 45 minutes. It should be very straightforward. Um, Honestly, it's simple. So, um, yeah, buckle in. It's about to be an amazing ride. So the setup for this is, for those of you that don't know, we both work at Databricks. Ben is now the TL for open source ML Flow. And prior to that, he was working in the field, working with customers. Working with customers is what I currently do. So customers come in and have a problem. They need a ML implementation built. They need data engineering pipelines built, and they sort of aren't quite sure how to do this in a scalable fashion on the Databricks platform. That's where professional services come in, and they can sort of get the prototype built and also educate the customer on how it should be used so that they're self-sufficient going forward. So it's like consulting, but we have a lot of say in how things are developed and what projects are taken on. So with that, I do a lot of ML work with a bunch of different customers, and recently I gave some feedback to an unfortunately unnameable customer on how they should be developing code. And we're sort of going to go through that checklist at a high level, changing some of the words so we can't get sued. And Ben will essentially use his massive amount of experience to comment, and then I'll also have some funny little anecdotes as well. But yeah, that sound good, Ben?
Yeah, definitely.
Cool. So, taking a step back, you've worked with hundreds of customers over the past whatever number of years, 5 to 20, depending upon how you want to count it. And I was wondering, what are the most common issues that you see with applied data scientists, specifically in the past several years? Because hopefully the field has evolved. So, what is still a very problematic code style or discipline that you have seen?
So last couple of years, I haven't seen too much because I'm pretty removed from that. But as you mentioned, I used to do your job years ago, and before that, I was the person creating the problems. um, and I'd learned by working with a bunch of different people and having software engineers tear my code apart, because I wanted them to learn. I told them, like, tell me how bad this is. And sometimes, early days of me doing that, they were like, dude, what are you trying to do here? And I'm like, oh, here's all the APIs. And they're like, no, no, no. I should be able to read your code and understand what's going on. Uh, it's not written clearly. Like, there's these massively long lines. The text is super dense. There's no comments anywhere explaining like these complex operations. Like, why do you have a 3-layer deep nested for loop here in Python? Like, what's going on? And then explain it to the person. And they're like, okay, we can refactor that in a simpler way. But also, when you're doing something like that, you need to let another human know what you're trying to do here, because this is just complex and it's hard to read. And if we can't simplify it, then we need to let people know like why this is necessary and what's going on. So I'd learned tips like that over time. And then when I became, facing customers directly, and the list that we looked at before we started recording, it looks almost identical to things that I've written 4, 5, 6 years ago when doing those initial reviews of people's code. And I think you gain that wisdom because you've just seen it so many times. You've seen so many different people and so many different organizations do the exact same things that are things that I was doing more than a decade ago, and having experienced wise people tell me, like, please don't write code this way. It's
Yeah.
so hard to read it. Um, But to get back to your question, the thing that I've noticed over the last couple of years in the big shift in applied DS, applied data science, machine learning, is that there's more newcomers coming to, visit our little fun party. Uh, when you get more new people coming in and trying to solve things with complex algorithms that take data in and predict something or perform some form of inference on that, you're dealing with a lot of complexity out of the gate, right? You need to think about what data is going in. Have I cleaned my data? Is my data labeled properly? Are there issues with the data that's being used by this algorithm? So you have all of the complexity with data, and that's not even covering getting data into a place that you can use it for training a model or interacting with an algorithm. There's just so much area space that you need to cover as a data scientist if you're doing, you know, what people would call like full stack DS or, machine learning engineering. You're touching a lot of different things and there's a lot of disciplines to understand. But common amongst all of those things is writing code. You're interfacing with a computer to perform instructions on these things, acquiring data, manipulating it, doing evaluations on it, consolidating it into some sort of vectorized format that can go into an algorithm, using that algorithm, training a model, evaluating that model, packaging that model with dependencies, then pushing it to a place where it can be deployed either in real time or used for batch inference. There's so much to learn there, but it's all one common foundation. And I know that some people will argue and say, well, those could be different languages. Let me break that down for you. To like a professional software engineer, it doesn't matter what language you're using. And I know there's people out there that are like, this language is great, this one sucks. If you're one of those people that engages in that, go ask somebody who's been writing software for 20 years and ask, like, hey, what do you think of this language? They'll have positives and negatives to say about every language. It's not a, hey, this language is so much better than this other one, or this one allows you to do all these cool things, so it's so much superior. No, they're purpose-built languages, provided it's not some highly esoteric piece of junk that some idiot created. But mainstream programming languages, they all are designed and maintained by very smart people uh, to serve certain utility purposes. They can do certain things really well, and some other things they can only kind of do. So I wouldn't worry about that stuff, about like, oh, well, if I need to use Python for my whole stack. It's like, no, you don't. And don't dismiss like JavaScript because you don't really know it that well. Go learn it and see what it's good for and how it can be used, because they all have utilities. But
Yeah.
the thing that I've noticed with the newcomers coming onto the playground and playing with this stuff is that so few people think about, they're so focused, I should say, on getting something into production, whether it be like, hey, I have a scheduled job that retrains this model or does this thing, and then it's going to run inference on my data, and I'm going to get predictions, and we're going to use them. Cool. Uh, that's what people are focused on, and nobody of these new generations of people that are like, it's their first time getting something in production ML. So rarely do I hear somebody say, what's our production maintenance going to be like? And when are we going to retrain? And what is that process going to look like? And what about when we have to change our features? Like source data tables change, or the ETL pipeline changes, or we get new data that comes in that can make this better, or existing data is going to change in a way that's going to make this thing blow up in our faces. That, after we release, what next sort of question and planning, that's what I don't see very much of.
Got it. All right. So before we get into that, that's sort of a secondary topic that I would like to address. Let's play a game.
Mhm.
I'm going to give you a code style or code trait issue. Um, Rate it from 1 to 10, 10 being very important that it does not continue, 1 being it's fine, who cares?
Sure.
Cool. All right. Definitely not coming from a specific list that I'm reading off of my screen right now. No documentation.
Depends. Um,
1 to 10 first.
10 being super bad practice, 1 being
Yeah.
not a problem. 7.
Okay. So how do you define documentation then?
If you are writing something that is going to be used outside of your team and you don't have some sort of guide, so if it's within your company or your organization and you're you're developing something that another team is going to use, you should have some sort of whatever your internal standards are for API documentation. Um, that should be generated. So there's tons of tools in any language you choose where it will lint your definitions of modules, functions, classes, methods, traits, whatever, and it'll auto create documentation for you, just the API docs. And if you don't have that as a bare minimum, uh, good luck. You're now effectively technical support for whatever you're pushing to another team. Every question that they have is coming straight to your team, and it's probably going to waste a ton of your time and frustrate both you, but more importantly, the people using your code. Because you never want to force people to have to look in source code to figure out how to use things. That's that's bad. Uh, if it's something that you're giving to another organization, like, hey, we packaged this code up for you to use to solve your problem. Uh, hint, hint, field at Databricks, and you're not providing 2 levels of documentation. One being API docs, and the second layer being a very high level, like with examples of like how to use this thing. Um, then you're failing. Like you're setting that team up for failure, which is bad. So,
Yeah, that is bad.
but if it's something, and then the other extreme to this, or the further extreme to this is you have this idea of an open source project you want to release out into the world, and you think it might be worthwhile. Like some other people might get a kick out of using it. Uh, Create a docs webpage. Like they're super quick to build. You know, if you're on Python, which a lot of data science stuff is, read the docs.io. They give you free website hosting as long as it's an open source repo. You don't have to pay anything. You just generate a key, generate your docs, like write simple Sphinx docs, or write them in Markdown, whatever you want, and read the docs format. It'll create a web page for you. Set a template or a theme to it. Make them look however you want. If you want to write some CSS, go ahead, write some CSS. Make them look unique. Um, but at a bare minimum, like create docs website for people to look at.
What about
Other,
just what about docs for your team for internal contributions? Because the
yeah,
users are very important, but what about your
yeah, that
team?
was where I was going. Is like the other side of the house, which is nobody outside of your team is ever going to look at this code, use this code, maintain this code, or interface with this.
Mhm.
It's like an internal job that runs, that does something, like builds a model and deploys it. Uh, you don't need API docs for that. You don't need, uh, you know, comprehensive examples and documentation with that. Your company might ask for that. Your manager may tell you to do that. If they do it. Like that's part of your job. But if you're trying to decide whether this is worthwhile or not or required, I would say no. Uh, but your code had better be documented. So the source code, uh, there's some techniques that you can use to make it so that you have to write less, and that is writing simpler code. Um, the second one being like use really good variable declarations, like the names that you choose. Make it so that it's very self-evident what this thing is doing. Your function and method names, they should be very clear about what their purpose is. That's self-documenting code. It's great. But you should also have, if you're writing like Python, right? You declare a function, create a very simple PyDoc string. If you don't want to write it and you don't really, you're not really savvy with writing those, do like you've done. You wrote an interface to ChatGPT or GPT-4 model that'll create PyDoc strings in Google style format based on code that you pass to it. It's
Exactly.
really good at doing that. And then just copy, paste into your repo. You're good. But if you don't have that, uh, you're just setting your team up and your future self for a lot of frustration. Somebody looking through code and a lot of stuff in data science, it's not always like the simplest code that you could write. Uh, some of the stuff that I've seen recently, now that I don't do that stuff anymore, I do, arguably the boring stuff now with writing APIs and developing stuff like interfaces. But when I have to look at data science code, a lot of times, if it's well documented, I just kind of read it. And I'm like, yeah, that makes sense. That's pretty complicated, but I don't think I could write it in a simpler way. Whoever wrote this did a really good job,
Mhm.
and they documented it, which is great. And then I've seen other stuff where I'm like, hang on a second, I need to read through this code about 4 times and refactor it in my head to break out what the heck is going on here. And then you're just like, why didn't they use comprehensions here? Like, what's with these 5 empty lists that they're creating, and then they're appending stuff to it based on index position? Like, what is this nonsense? So it's really frustrating, like reading code like that, and realizing that it's made so much more complicated than it needs to be.
Right.
Yeah.
Cool. All right. There's documentation. I think I agree with everything. One thing that I've been really enjoying in developing specifically customer code, but also project related code, is it's really satisfying to have a function that just does not need a doc string. So if it's a one-liner util and you have a good name for it and you have type hints for the parameters and the returns, that is really, really self-evident typically about what it does. And even if it gets a little bit more complex from a utils perspective, it's not always necessary to have doc strings. And people think that there's a lot of work that's required in creating thoroughly documented code. If you just write self-evident code from the beginning, it's actually really efficient. And then your complex main function, for instance, yeah, throw a lot of docs in there. But overall, if you just have concise code that's well named, it's really useful. So, second one. All right, this is something that I have seen in, I think, literally every code base that I've seen at Databricks so far in the past like 18 months. There's typically a lack of modularization. And so modularization refers to either breaking things up into different directories at the highest level, then into files, then maybe into Python classes, and then all the way down into functions. So when you think about modularization, 1 to 10, how important is it uh, to get it right?
For a language that a data scientist is going to be using, and I'm wrapping up SQL, Python, Go, um, JavaScript, Java, and Scala, all in this same big bucket here with like data science languages, uh, plus C++. That's also used. Um, I'd say it's a 10. It's well, let's call it a 9. There
Yeah,
are some
wow.
cases where you don't need to do it.
Why?
If the code that you're writing is, well, there's two places where I won't do it. One, the code that I'm writing is inherently simplistic and is intended to just do this one thing. Uh, and it's so short that I don't need to create a function or any sort of encapsulation because it's intending to do this one thing. Example of that, a bash script. If I'm writing a bash script that does something with creating a bunch of directories that I'm going to be, you know, loading files into, and I want to fire this bash script off from Python code because I don't want to have to write that logic in Python, um, then that would be a single use, single purpose script that it doesn't need any form of abstraction within it. It should be just purely declarative. I'm doing these actions in this order, and then I'm exiting or I'm throwing. That's one case. The other case is prototypes. So if I'm working on a design for something and I need to prove out some ideas that I have or some options about where to go in, potentially implementing something, I have to write code to prove that to myself and to others. Like, hey, here's how this is going to look if we go with option A. Here's how it's going to look in option B. And then I think option C is going to be better. And here's the example of that. I'm not writing abstract code for that. I'm not like creating multiple modules and then defining classes and writing a bunch of methods and interfaces, designing all of that stuff. No, I'm writing a function that represents what a method will eventually look like, or that interface will one day be. And all of those three options, A, B, and C, they're all in the same file. So I'm not creating three separate files because in the design doc, I'm not including these files. I'm highlighting Command C, Command V. I'm just pasting code into the design doc. I don't need it to be clean. I know where it is in this doc. Nobody else is going to open this file that I've written that stuff in. So I don't need proper code design.
Right.
Unless the thing that you're designing is the actual code design, which usually that's an implementation detail and you shouldn't be worrying about that. Trust an engineer to do that correctly. It's their job. But yeah, those are the two exceptions, I think.
And on the flip side, if you're looking for reasons why you should have your code be in sort of a modular format, I think the most important one is the fact that you can easily unit test functions. What do you think is the most important reason to modularize your code?
Simplifying. You will know no greater pain than working on a time-sensitive bug fix for something that you fix this particular functionality in the location that it's failing. And, your test validates that this fixes the problem and you're all set. You ship the code, everything's working, like seems like it works great. Fast forward 2 days and the exact same failure mechanism shows up, but in a different use of your code base. And then you realize that, oh no, that one thing that was failing with that first usage, that code or that logic is actually copied in 17 different places throughout our code base. And then when you go back and look at those 17 different implementations, or that you realize that that code block was copied 17 times on the initial release of the code. Going back through and doing this audit that you now have to do because you done screwed up, son, by not applying your fix to the 17 different locations, you realize you can't apply your fix to these 17 locations. 4 of them have logic in them that has been mutated since the original release that prevents you from fixing the problem. Now you have to go back and refactor abstract and fix this for all of those cases, which, if the code was designed properly from the start, when you bifurcated that functionality in those 4 separate, custom use cases, you would have abstracted off of that original implementation, or you would have said, okay, this needs its own function because this is different behavior now. So let's create a new function that is different. But because you didn't do that, or nobody did that beforehand, you're now forced to come up with that level of abstraction, fix that problem, now fix the root cause problem of why you're touching it in the first place, and then make sure that all of those code paths work properly. So what could have been a 30-minute fix if the code was designed well turns into 5 days of refactoring, validating, testing, rewriting unit tests, maybe rewriting integration tests. You just wasted tons of time because somebody, when first developing it, didn't realize that they should have abstracted something and instead just copy pasted functionality multiple times.
Yeah. All right. So to sort of summarize, modularization is essential because if you need to make some changes, you only have to typically change a single thing or maybe a couple locations. But if you don't have dry or don't repeat yourself code, then you have to go make those changes in a variety of different locations, and it's just a headache. And then also, you can't really unit test it if it's not in a function. I mean, you can, but the units cease to exist if you have a monolithic script.
Yeah. I mean, if you're testing a script, you're testing IO, like
Exactly.
input. That's an integration test.
Exactly. All right. So we touched on another sort of frequently found issue, which is non-dry code or or lots of repeat code. But let me find another one. So, what about if your code, and this is actually a really interesting problem that I was trying to figure out how to make the organization change their style via, it was like a culture issue. It's not really a code issue. The issue was culture at its source. And this took the form of lots of code that was just simply commented out, lots of bad code that is just like not, it's not used ever. For instance, like you have a entire if statement that will never evaluate to true, or you have just objects or transformations that are occurring even if they're not relevant to the downstream output. So it's clear that many people sort of built this over time. It was not properly maintained. It was not properly refactored. And I don't even know if there are code reviews. So, with those problems of just like messy code, how do you go about changing the culture? Well, actually, going back to our original game, 1 to 10, and then how do you go about changing the culture so that that type of thing doesn't happen?
I mean, that's an 11, man. Um, Now, to put it in context, I'm not a stickler for style, um, which is weird when you think about it. But, because being a maintainer of a super important and very widely downloaded open source package, um, you would think that all of us are dedicated to code style, and that's like the biggest thing. Uh, the project is, we're not. We use linters. And one of the things that a linter will do is fix all of that nonsense for you. So if your code isn't structured well and it's not, the right indent, not indents, the Python code won't work if it's not indented properly. But if it's not, consistent with regards to, okay, after my doc string, how many lines of space should I have before code starts? At the end of every file, should I have 1 empty space or no empty spaces or 2? Or so using a linter is a way to prevent broken window syndrome. Code bases are, I personally feel they're way more susceptible to broken window syndrome than the original analogy of windows broken in a town, everybody stops caring about what their town looks like. Trash piles up in the street because people are like, whatever, there's broken windows and there's garbage on the street. I can do whatever I want. So a code base is way more susceptible to that. So if you see a lead, like a tech lead committing code to a repository and they're leaving a commented out code within their commit, or they're not doing a follow-on PR and they're leaving stuff like to-dos in their code
Yeah.
for like, hey, sometime in the future, let's do this. It's like, that doesn't belong in the code at all. But if you're a junior person, you're seeing a super senior person doing stuff like that, you're not going to care. You're going to leave all sorts of garbage and BS in your code and push it, and nobody's probably going to say anything about it. But it's such a bad habit to get into, because if you don't care about stuff like that and your code is just a hot mess to look at, why are you going to care about your implementation or whether your code's tested? So it's sort of a pride in your work sort of thing, and keeping that stuff sanitary. So using auto linters and rules-based engines to keep code clean, it'll do stuff like flag if you set the rule and enable the rule. Like, is there a block comment of something where there's just code in it? There's linters that can detect that and fail. It'll do like a pre-commit check and say, you can't merge this because you have commented out code in your PR. And I know a lot of particularly junior people really love to do that because they get scared and panicked. They're like, well, I wrote all this stuff and I don't want to lose it. It's like, open up your Notepad app, or
just save it.
create
Yeah.
a personal repo. You can commit that junk to that if you're so terrified that you're not going to be able to figure this out again. But what I'd like to just say to everybody who has that reaction, or like, I can't delete my code. It's like, you're smart. You figured it out the first time. You'll figure it out again. It's not that important to keep that around. In fact, it's way more important to delete that from your code base than to keep that around. So no code is sacred. It's not magical what you created. It can be built again. Delete it. And with some of the other nasty stuff I've seen is like print statements everywhere in code. That's like a job that's going to be submitted to an automated production system for like a cron schedule, and there's print statements in it. It's like, who's going to see that? Maybe your production system is capable of you viewing the instance that ran on a particular date or time. Cool. Awesome. I guess you could manually go through and look at that particular run and see the output. I can tell you that no software engineers do that. We use this thing called logging, and it allows us to just parse through hundreds of thousands of lines of debug logs when we execute something, or when we're trying to see what caused something to fail. Your log should be your guide to the state of the execution of something. If it's super important that you need to know that something ran and the output result of it, log it. And you can have it as a reference for troubleshooting in production. But if it's something like the thing that drives me nuts, man. Oh man, I've seen this so many times, and it just baffles me. Where people will put print statements in to say that code executed. It's like, done with stage 1, starting stage 2. It's like, who is that for? Like, if your code executes to the end, you know it got to stage 13 and it completed, because otherwise it would have thrown an exception.
Wait. I've seen this a lot, and I actually use it sometimes. I have 13 stages. My code fails. I want to know what stage it fails. What's wrong with having a print statement? I mean, obviously, use a log instead. That's better. But
yeah. So if you need to know that, create a logger instance and put in there initiating stage N. Whatever stage it in, you're processing through a loop. Log it. starting stage 3,
Yeah. Okay.
stage 3 complete starting stage 4. But having that as print statements within your production code,
Oh.
as it's going through and
Yeah. Okay.
iterating through, you're just going to see in standard out these blocks of text that's like start stage 1 started, and people format that in like cool and interesting ways. It baffles me, man. Like drives me not. It doesn't drive me nuts. It's more just like a curiosity. Like, why do people do that, and why do they find that so useful? Like, are they excited that they're able to get a computer to print to standard out, and that's like they really like ASCII text or something? Like, I don't get it.
I like ASCII text.
There are times where you can do interesting things to aid you detecting something in the logs, where you're saying like, hey, as part of my exception that might get thrown, I'm wrapping my execution in a try catch. Create something that's visually distinctive if you're frequently going back to your logs and trying to find a particular event that's happening. Yeah, do some ASCII art and put it as part of your stack trace. uh, don't do that in a software engineering capacity at a regular company. People will probably get pretty pissed. But if you're doing it for applied ML, why not? I've had the Picard facepalm as part of an exception stack trace before in ASCII art because I thought it was funny, and other people thought it was funny too. Um, that's a nightmare for parsing logs, though. So, you know, I wouldn't condone doing that for prod. But as a joke, it's pretty funny.
That is pretty good. Yeah.
But there's just some baffling things to me with regards to print statements sometimes, um, because even if you were to log certain things, like, oh, I want to calculate all of my evaluation metrics, and uh, you know, in their prototype they have a bunch of print statements, so you can, and I do stuff like that. Not that I build models anymore, but when I'm running, through a prototype or developing something, yeah, I use print statements all the time. It's to tell me the state of things. If it's complex enough, I'll start a debugger and I'll step through processes. Bigger the code base, the harder that gets, though. Like running through a debug, that takes a while on a complex code base. So sometimes it's easier to just write a print statement. Give me the state of this object right now when I execute it. Super useful troubleshooting technique. I don't leave that in the code, though. Certainly wouldn't leave that in, a framework code where hundreds of thousands of people are using this thing, and then all of a sudden they start seeing all these print statements come out while they're doing, using the tool. People will have questions like, what's going on here?
Yeah.
um, so you definitely don't want stuff like that. And logging is good, but
Heard.
if you're logging stuff like metrics and parameters and things as a part of what you're doing with modeling, use a tool like MLflow. That's what it's there for. It's to provide a way to safely store for long-term access the state of things when you executed it, and that's what's one of the big things that it's built for. So you don't have to search through notebook runs and try to remember what the heck was going on at this time.
Yeah. All right. So we've listed some issues that I've been seeing over the past 18 months. And one of the most challenging things, so we're brought in as trusted advisors. Theoretically, collaboration differs between different organizations, whether they're very technical or non-technical, whether they like Databricks or they don't like Databricks. There's a lot of factors at play. But one of the core things that we're tasked with is influencing sort of culture and design so that they can be more effective in the Databricks environment. And so let's say you see some of these issues. You don't have modular code, it's not very dry, and other things that we talked about. Maybe there's a lack of documentation. You are in a room with the head of engineering for ML ops, data science. Let's say it's just an umbrella person that owns all of those functions. What would you say to them in a concise manner to get them to change the culture so that the code quality is better?
I wouldn't do it blindly. So I would come prepared to that meeting. And funny that you mention it. I've been in that meeting room probably about 50 times. talking to some executive who's asking, "What's your take on my people? What's wrong? Like, why did we have to bring you in here?" Um, and breaking it down. But I don't just have a casual conversation with that person. Um, I bring the evidence. So I'll do. In the past, I would do a full review of randomly selected jobs that they're trying to run or they wanted me to look at. Or I asked them, "Hey, can I get access to that thing that's running in prod? I want to see the source code." And I'll read through that source code making notes. Just taking notes, this file, this line, here's something I saw that's weird. And at the end of every file, I'll go back and rewrite the things that I found so that they're consistent with each other. I'm like, hey, I found this type of issue. This is a type 17 error, in my opinion, of like code development error. And I'll count up all of those instances. And I'll have another document that's the pre-read to the report that I'm going to give to their executives. That document is going to have the penultimate example from their code base with references to the file, the commit, and the line number of where I got this snippet from, and what, like a 1 to 2 sentence explanation of what I think is bad about what I'm seeing here. And I'll have that example, whatever the best example I can find, usually the most egregious example of this problem, and I'll list that out for all the problem types that I've discovered throughout the code, like that one deployed code base. And then when I'm doing my final write-up of what I've seen, I'll break down as a summary. Like I'll leave all of those raw, examples that I found and each instance that I found within that particular code base. I'll leave those as supplementary things to the report. But in the summary, I'll say, hey, I looked at 11 jobs that you have running, and here's the tally out of total cumulative lines of code across all of these. This is how many instances I found of problem number one, like bad naming convention. Like it wasn't clear to me reading this code if I deleted all of the comments from the code and then I read this variable, it was not clear to me what this was for, like why it was even declared, what it's being used for somewhere else, because it's being called. It's like the return from this function that's being called by this other function that then passes it on to this other function. So I'll just tally that up and be like, hey, there are 87 instances of that type of error, like bad naming convention, in this one job. And then the summary will say, like, across these 11 jobs, I found 973 instances of terrible names. Sometimes that's the number of variables that were declared within all of those jobs, because they use some weird, SQL stored procedure, naming syntax from the mid 1980s. Like everything's an acronym, it's all uppercase, like everything looks like constants in Python. You're like, what are you doing? Like, what is this representing? And they ask somebody on the team, they're like, oh, well, that's this thing from this business unit and then this product line. And it's like, why? Like, why would you name this way? Well, that's our standards. We have a code style guide that we have to adhere to. So I would point all these things out and saying, these are not, like, this is not how modern software is developed. And this is way more complex than it needs to be. Then for one of those examples that I find of it being confusing, I would take their exact function or whatever they have declared that I said that I felt that this is a good example, and I would refactor the function, not just to fix those issues. I would refactor it the way that I would want that function to read if I was maintaining the code. So which would usually mean I'm splitting the function up into 3 separate functions, or I'm greatly simplifying like the way that they wrote this code to make it much more legible, just easier to read and follow. and then point that out. And that's the stuff that I would cover in the summary. Like, hey, a lot of those executives at companies that are in charge of ML ops teams or, you know, data science teams, they used to do that job maybe 10, 15 years ago. They were involved in software in some way. So they understand like the difference between what you're about to show them. If you make it that obvious, like, here's what your people are doing. And sometimes they're like, okay, yeah, that looks good. They're like, I rewrote it. And which one would you prefer to look at? Like, can you
Yeah.
tell me like, which one's easier to maintain? And always they're like, well, the second one, yeah, that I can even understand what that does right now. Like, well, to the computer, these are the same thing. So
Yeah.
let's make it easier for humans.
So, first, perform an audit. Second, for key problems, write a solution that is best practice. In your experience, after delivering that to an exec, are they bought in for sort of refactoring all the code, or do you have to connect it back to a higher level issue like number of bugs, revenue, ease of changing or modifying something? Or is that sort of uh, bad versus good side by side example? Is that enough to get buy in your opinion?
That's never enough to get buy-in.
So how do you connect it back to the higher level components?
Before I show a summary about anything, I ask questions about, hey, what are you struggling with? Like, why am I here? Why did you pay money for me to be here with your people? And typically there's a lot of stuff like, hey, the team velocity is terrible, or it's just really complicated getting this solution out the door. We need help. Or, hey, we're on this new platform, Databricks, and we need to get it running, like our existing solution running. At the end of the day, the reason that any company hires a consultant is because their own internal practices are so bad that they can't figure something out themselves. So they're always their own worst enemy. It's either that or the team just is not staffed
Right.
enough to do that project, which that happens in consulting all the time. It's like a really great world-class organization that's doing stuff, and they have a backlog of work that's like 2 years in duration. So they need to hire some consultants. But you'll know that walking into an engagement with a company within the first 10 minutes of looking at their code. You're like, oh, yeah, these people definitely know what they're doing. I just need to write code in the style that they write so that it'll pass, PR review. Um, but most of the time in my history of interacting with companies as a consultant, 95% of the time it was the first group where it's not that the people are stupid. It's not that they're lazy. It's not that they're incompetent. It's there's a history of bad practices that have crept into their development process or their maintenance process where they can't actually do this thing because they're perpetuating these bad habits. They're writing dirty code. They're writing like overly complex code. The code is so hard to modify and maintain that projects get shipped to production and then they get turned off when they're no longer useful because the model's just junk because it's never been retrained or updated or modified because it's too hard to do that. So that's the conversation that I have, is something very similar to that, is explain like, hey, like the meeting room that we're in right now that I'm talking to you, uh, I've been in this room 43 times before in the last 3 years. And here's what I've told them. And here's the results that happened for the ones that listened to me. And here's what happened to the ones that didn't listen to me, that wanted to argue and not listen. I'm leaving it to you to decide whether you want to listen to what I have to say, um, or ignore everything that I have to say. I would prefer you listen and I could work with your team to make this better. Or if you tell me to shut up and walk away and just go build code for your team, I'll go and do that. But I don't think that's the right thing for your organization or for your future tenure at this company. And I'll flat out, I've said those exact words to executives before, and the vast majority of them are like, let's go with option one.
Yeah.
Some have done option two though, and I find out 3 or 4 months later after I leave the engagement that they got fired because somebody above them was like, this person sucks. They're the problem.
Yeah, double clicking into that, there's a lot of very organization specific culture and even people specific culture that makes influencing behavior really difficult. In your experience, what are the traits that are common for people that don't listen to your advice?
I mean, I'm not saying that the advice I have is
Well,
sacrosanct. It's
don't
not
listen
like
to advice in general. Like the people that are the problem essentially, or part of the problem.
it's usually hubris. Um, it's usually somebody who really and truly believes that they're the smartest person in the room, and they just don't want to hear from anybody else. Like I guess they take it as like a personal attack to their ego or something. I don't know. Uh, but they're the reason why some jobs suck for technical people. Is
Right.
people like that. Uh, Even if you're somebody who adheres to all of the best practices, whatever that means, like you generally have good ideas that work out well because you've tested them over time. Even if you are that person and you don't adapt to change or don't listen to other people and get their feedback and understand why certain things are the way they are and then adapt your methodology to fit within those needs, then you're just as bad as the person who refuses to listen to any advice. It's still hubris. You think you know everything, and nobody knows certainly nobody knows everything, but nobody knows as much as they think they know, is my experience. And being open to listen and to have a discourse with the team members and with leadership when you're coming in as a consultant and talking to those teams. And even if you're within a team at an organization, you're trying to make things better. uh, Listening is more important than talking. And then the only thing that's more important than listening is evidence. And if you can provide solid evidence that like you did A, which made B happen, and B is usually a bad thing that happened, and here's some examples of people doing C, which leads to D, a good thing happening. Like here's the data on this, and this is the overall consensus that we found. And if people ignore that, then there's not much you can do. you know can't save everybody.
Yeah, that said, in my experience, it's really rare if you deliver your argument cleanly and concisely, and also with like just general some level of like social competence, and then B, if your argument is sound, it's really really rare that people will not understand it. And now there are a lot of external factors that can override your argument that make it invalid in a broader context. But yeah, I haven't worked with many people that aren't open to truth. So
And the important thing from giving these messages that I found, um, nobody in a position of management has the direct ability to change the behavior of like the troops on the ground. They can give a mandate like, "Hey, write cleaner code." The people are going to be like, "What the hell does that mean? We already
yeah,
write clean code." Whatever. They don't know what they're talking about. So they know that, and any good executive knows that. The inmates run the asylum when it comes to day-to-day tasks. So if you want to win over the people that are running the asylum, like the actual individual engineers, data scientists, MLEs, MLOps people, if you want to convince them, it's never about telling them what is wrong. Most of them already know what's wrong. Some are clueless, like they had no idea that these were bad practices, and they're just perpetuating what they've seen before. We're pattern recognition machines as human beings.
Right.
We follow patterns that we see. So in order to win them over and to make the argument listened to, it's never about pointing out what's wrong. Like, nobody wants to hear that. Or, some people do like to just hear the brutal, honest truth. And then you need to think about what happens. Think about that as your production deployment. If you're a consultant, your deployment is you're telling them the bad news. The maintenance of that production, what happens after, the 3 months after, you need to give them that vision, which is, here's what things are going to be like if we make these changes. Here's how much easier things are going to be. And I'm here to get you to that point. Let's not think about what's going on right now. We know everything's on fire. We know things are bad, or this is really complicated and it seems like it's impossible to get this project done because we don't know all these things and there's all these unknowns. But if you give them the vision of what it's going to be like after this thing is successfully running in production, like, hey, whoever's on call, and they're like, on call, what's on call? We don't do that. Like, we'll get to that later. But if you tell them, like, hey, when you're in maintenance mode for this thing and you need to update the feature data set, if we follow these guidelines, here's how easy this is, like how fast this will be. And if we use these tools while we're doing it, this is how we're going to have, lineage, and we're going to understand when this change happens. So when we pull the data for attribution analysis, when an executive asks, how much money is this making us? This process is going to be very simple. It's going to, it's going to take 15 minutes instead of 15 days. So this is why we're doing this stuff. And usually when people hear that, they're like, whoa, this person's going to help us make all of these problems go away. Yeah, this is awesome. Let's do this. And the way that can blow up in your face is when they assume that you're just going to magically do all that stuff for them. That doesn't work. It's the communication has to be to both the executive and those team members, like, hey, we're going to do this together and we're going to go through a lot of pain. But at the end of it, we're going to understand a better way of doing things. That means we're not struggling to get one model in production, but we have so many requests from the business with our 37 models in production that we need to hire more people that can be trained to do what we're now doing so that we can continue to deploy and make this company tons of money. So and that's the goal.
Right. Yeah, it's really interesting how important cross-functional skills are. Like, you were basically describing sales, and sales with prototypes and being intelligent about identifying the right problem, but it fundamentally is an aspect of sales. And so, yeah, it's really cool. And that's honestly one of my favorite things about work, period, is using different parts of your brain and different parts of your skill set to tackle uh, diverse problems. So,
Yeah. I mean, consulting it's an interesting field from the experience that I had of it, where, it is like a merging of many different like disciplines that you need to be. You don't have to be perfect at all of them, but you need to be good at a lot of them in order to be successful. And the number one biggest thing that I've noticed, there's two, I should say there's two. There's two things that you have to be a good consultant, to be a great consultant. You can have one of them and be good, but if you want to be great, you need to be really strong on both these things. And that is technical capability. So can you read code? Can you figure out what's wrong with it? Can you write good code? Can you teach people how to write good code? That sort of thing. Can you do a code review very well? And the second thing is empathy. Can you actually empathize with the pain? When you read that code, can you empathize with the people who are maintaining that or who are writing this code about how difficult this must be? And that's something that I always tried to do, is like, when I'd read the code, sometimes I'd read a code and I'd just like start kind of laughing, uh, not in a mocking way, but just sort of in a laughing at the bizarre. Just like how, like, I can't figure out how somebody thought to create this.
Yeah.
Like, who thought this was a good idea? It's so absurd to me that even when I was first starting out, I never thought to employ my creativity to create something so bad. So it's like intentionally written to be as difficult to understand as possible. And I just would find stuff like that funny. Um, it never is intentionally written that way. It's just somebody doesn't know better, or they're perpetuating really bad habits that were probably started decades ago. So immediately after getting a good chuckle out of something, I would start thinking about imagining myself being that person writing this code, and I would try to get into their headspace
Right.
of like what would have driven this person to write the code in this way? Like, is this a series of edits that they did and reworkings in scripting, and then they finally got something to work and they just copied it and pasted it into a function definition? Or was this just a refactoring gone wrong? Or like, how did this come to be? Right?
Right.
And when you start thinking through that and imagining what it must be like working at that company, working in that team, and producing that hot garbage, you start to understand these people a little bit better. So when you do have conversations with them, you kind of see things from their perspective, and you can think about ways to reverse the bad patterns in a way that is understanding instead of
Yeah.
mocking. You want to piss off a team of data scientists, mock their stuff and say that it's garbage and just like trash their code. That's such a jerk thing to do. Not constructive. Nobody will want to deal with you or talk to you ever again. It's bad. So the constructive feedback, but also the empathetic, is super critical.
Heard.
And
Yeah.
that's not just for consultants, by the
Yeah. I
way.
was about
That's
to
for
say.
any team lead out there or senior person should be thinking about that as well when they're reviewing code from their junior people. Like, how can you mold this person not into an image of yourself, but into the best image that they can be?
Right. Yeah. Empathy is just necessary in a lot of aspects of life. So
But
completely
it's so
agree.
devalued in tech, in my opinion.
Mm.
Like, some companies, that's their culture. Like, you walk into their engineering department, you talk to them, and you're like, wow, all these people like really like each other and they really get along. They might not be best friends, but they all respect each other, and like, it seems like everybody enjoys working with one another.
Yeah.
And then you go into another company, into their DS or Eng department, and you're like, man, everybody hates each other here. This place is super hostile. Like,
Yeah.
that meeting was painful. Like, that tech lead jumped all over that other, you know, principal engineer, and it's like, what is going on here? No empathy, no no personality being
Yeah.
employed in those meetings, and you're just like, man, what a terrible place to work.
Yeah. Well, luckily we don't work in that environment. But if you
No.
do, I'm sorry.
Sometimes the grass is greener on the other side.
Yeah, for sure.
Find another job.
All right. So I will wrap. Lots of really good stuff here. I think it's kind of tough to condense everything into a few concise bullets, but here are some things that stuck out to me. When you're trying to influence culture to leaders, just do an audit. So go through all of their practices or do a random sample and find problems and bring them up. And then from there, you sort of have to take on a salesy approach of saying, this is where you're at now. This is what it should look like. And then this is why it should look like the way that it should. And with that sort of 3-step process, you can then typically have some solid results. Code should be as simple as possible. That's a very robust underlying design principle. Um, and then if you're looking to sort of get people to think long term about how code should be designed, uh, Think about maintenance. Think about how difficult it can be if there's a bug and if you have to fix something, or if you have to add a new feature in a weekend. How would that look, and how could simplifying the code facilitate a better process around modifying and adding functionality? And then finally, to be a great consultant, you need to be technically capable, but also extremely empathetic. Anything else?
No, I think that wrapped it up.
Cool. All right. Well, until next time, it's been Michael Burke and my co host,
Ben Wilson.
and have a good day, everyone.
We'll see you next time.